Okay, friends, this is lesson 3. We're going to learn about the product rule, and here we go. So by the end of this day, you'll be able to find the derivative of two functions multiplied by one another, and these would be great competencies to consider. Explain and justify your mathematical ideas and decisions in various ways, and explore, analyze, and apply mathematical ideas using reasoning technology and other tools. So be looking for that as we're learning together. And the first thing that we're going to do is just take a look at things that you know to be true. So for example, the derivative of x cubed and x to the power of 4 are 3x squared and 4x cubed respectively. It might be tempting to think that if you just multiply those together, 3 times 4 and x squared, x cubed, that might be the derivative of two functions multiplied. It turns out it's not, because we know that x to the 3 times x to the 4 is x to the 7, and the derivative of that is 7x to the 6, and those are clearly not equal. There you go. So we're going to try to figure out what it is. This is the product rule. I'll let you play around with that on your own, but I'll give you the gist of it. If you take the derivative of the first times the second plus the first times the derivative of the second, that should be g prime there, you're going to get 3x squared times x4 plus x cubed times 4x cubed. And when you add those together, you get the same thing. So what we're going to do is show you the product rule. Welcome to it. F prime g plus f g prime. This is the product rule. So now what I'd like to do is prove this to you. So the first thing you should be aware of is that the derivative of f of x using Newton's quotient is f of x plus h minus f of x over h. I think we know that. The derivative of g of x is similar. G of x plus h minus g of x over h is the derivative of g. Okay. Some other things you should know is that when we are taking the limit of a sum, it's the same as adding the sum of two limits. So as h goes to 0, this is x squared. As h goes to 0, this is x squared. X squared, there you go. Begin the proof. Okay, so here we go. Are you ready? This is a great response to this. So as being a newbie to proofs, this is going to be a bit of a weird one to think that we're going to prove this, and we're going to. Get ready, here we go. So if we have two functions multiplied, here's the function, and here's the adjusted function shifted over by h, and this is just Newton's quotient, y2 minus y1 over h. We're going to get creative. This is not obvious to you, and it wasn't obvious to me when I first read this proof and thought about it. But this would be somebody's life work or big work where they discovered, they wrestled with it and they tried it. This is what they thought. They're going to add and subtract that yellow term. And notice if we subtract it and add it, we've added 0, which means we haven't changed the value of the function. Okay, we're going to split these two functions into two parts, which I've done right here. Then I've split them into two parts. Now what I'm going to do is factor out common terms. Do you notice that there's an f of x plus h in this term, which I'm going to factor out? And you notice that there's a g of x here. I'm going to factor that out as well. So I'm going to factor out an f of x plus h there and a g of x there. Notice that what I'm left with is the limit as h goes to 0. What will that turn into? So let's answer those problems. So as h goes to 0, some pretty interesting things are going to happen. As h goes to 0, this is going to 0. This is, going to f of x. As h goes to 0 here, that's the definition of derivative. So that's going to be g prime of x. As h goes to 0 over here, this is going to be g of x. And as h goes to here, that's going to be the derivative of f. And there you go. If we rearrange them just a little bit, we can see that we get f prime g plus f g prime. The order there doesn't matter since we're adding. Okay, so now that's the proof. It's a good time to celebrate. This man knows how to celebrate. All right, be that guy. Okay, first things first, let's make sure we can write it. There's lots of ways of doing it. So if it was in terms of f of x's, it would be f prime of x gx plus f of x g prime of x. There are other ways. This is my preference because I don't like writing all those x's, but the above and the below have advantages. Okay, so this would just be f prime g plus f g prime. And with this notation here, it's the derivative of f of x times dx plus f of x times the derivative of g of x. So take your time to make sure that you know the product rule and can write it in different ways. Okay, this next move is we're just going to walk through how you apply the product rule, okay? And here we go. So we're going to start here, always convert it to exponential form. We're going to follow the product rule. The derivative of x to the half is going to be 1/2 x to the negative half times g plus f, and the derivative of x minus 8 is 1. It says collect like terms. Oh, sorry, by the way, I think I said write it as a combined fraction. So you're going to do that here. And notice as you multiply this all out, you have these terms. I'm looking for like terms. And so the 1/2 and the 1 is going to be 3.5 x to the half. Because of that negative exponent, I know that I can write it like so. In other words, with a fraction, and it did say combined fraction. So I'm going to multiply top and bottom of this one by root x. And in doing that, I have this term. This is a bit strange to me. I don't know. I should have been, feel like I should be multiplying the top and bottom of that one by root x. I don't know why I did that. Anyway, create the common denominator of 2x. There's lots of ways of getting to it, and then combine terms. Factoring, not necessary. You can see there's a lot of different correct ways of leaving this. And so there you go. Okay. This is sort of a common question, which we've seen here. Beauty. So basically what we're going to do here is, again, using the product rule, the derivative of x squared minus 7 is 2x multiplied by x cubed minus 2 plus this term here, f times the derivative of this. We're going to collect like terms. And remember, now what we're going to try to do is it says find the equation of the tangent line that passes through that point. So we're going to have y equals mx plus b is the equation of the tangent line. How do I find the slope when x equals -2? All I'm going to do is put -2 in there, there, and there. And when I do that, it comes up with a specific value. And I'll click on Desmos so we can do that. It turns out that the slope is 4. And so right here, the slope, when you put -2 in here, you get a value of 4. So we can change this to 4. And I'll use my beautiful blue there. So that's 4x plus b. And of course, if we want to find the b value, I certainly I take the -2 right there. I put the 30 right there. And so that's going to be 30 equals -8. So it looks to me like the y-intercept is going to be positive 38. Let's see if it is. And it is, in fact, there it is, and it's going right through it at 38. So this is a very tricky question, and I hope that helped. This is extra practice. Let's see, and there's a detailed explanation there. So I'm going to leave this extra practice for you to do. There's f, there's g, f prime g plus f g prime. You can take it from there. More extra practice. So I'm going to leave it at there, and you can also walk through this proof again. And I think we're going to leave this there. So best of luck. We'll chat soon.